So, if you're building a B2B SaaS application on AWS, you are going to hit a wall. It's one of the biggest architectural decisions you'll ever have to make. How do you handle data for all of your different customers, your tenants? Now, if you get it right, you can scale to the moon. But if you get it wrong, oh boy, you're in for a world of hurt with performance and security. So let's walk through how to actually get this right. I mean, it really all boils down to this, doesn't it? You've got one single platform, but you might have hundreds, maybe even thousands of unique customers who all depend on it every single day. So how do you design your database architecture to serve every single one of them, securely, reliably, and without one customer's crazy workload, tanking performance for everybody else? Okay, to make this all feel a bit more real, let's follow the journey of a fictional company. We'll call them SaaSworks. And just like most startups, they need to move incredibly fast and, keep those costs way down. And that leads them to their very first and probably the most common architectural choice. They start with what's called the shared schema model. It's really the simplest way to get going. You've got one big database, one set of tables for everything, users, projects, you name it, and every single row in those tables has a special column, tenant_ID, that basically just says, hey, this data belongs to customer A, or this one's for customer B. Now, for an early stage company like SaaSworks, this is kind of a no-brainer. The pros are just fantastic. It's cheap to run, it's pretty simple to manage, and adding a new customer is literally as easy as just adding a new tenant_ID. But, and there's always a but, the cons are just lurking under the surface. Security isolation isn't great, queries can get super complicated, and then there's the biggest risk of them all. The noisy neighbor. This is like the boogeyman of any shared architecture. It's the idea that just one tenant, one customer, can completely monopolize all the resources and just destroy the service for every other tenant who's sharing that same database. And this chart just illustrates the problem perfectly. Imagine tenant A decides it's time to run some massive, super complex annual report. Well, boom, suddenly their activity spikes and they're eating up 90% of the database CPU. And what about tenants B and C? Well, they're just trying to do their normal, everyday work, and for them, the application grinds to a halt. They're all victims of that one noisy neighbor. So for SaaSworks in their early days, this model makes perfect sense. The whole focus is on shipping new features and winning new customers, right? The motto is clear. You prioritize simplicity and speed, and you just deal with the risks as they pop up. All right, let's fast forward a bit. SaaSworks is a huge success, but now those noisy neighbor problems, they're happening more and more often. Their customers are getting bigger, and they're starting to demand better performance and much better data isolation. That startup model is really starting to crack under the pressure. So what do? They evolve. They move to the separate schemas model. Now everyone is still sharing one big database instance, but each tenant gets their very own dedicated set of tables, their own schema. Think of it like this. You're all still living in the same apartment building, but now each family gets their own private apartment inside. And of course, this brings a whole new set of trade-offs. The pros are huge wins. The data is way more isolated, queries get a lot simpler because you don't need that tenant ID filter everywhere, and you can even start customizing the schema for specific tenants. But now it's more expensive, and operations like doing backups and restores, well, they just got a lot more complicated. And this is really where leveraging your AWS tools becomes absolutely critical. For instance, using finely tuned parameter groups can help you manage performance, while having really robust IAM rules can lock down security and access between the different schemas. It's all about taming that new operational complexity that you've just introduced. So you can see the philosophy for SaaSworks has totally shifted. It's not just about speed anymore. Now it's about finding that perfect balance between supporting rapid growth and providing the rock-solid security and stability their growing customers are demanding. And that brings us to the final stage of our journey. SaaSworks has done it. They've just landed a massive enterprise client. And this client has incredibly strict compliance, security, and performance requirements. That shared apartment building approach? Yeah, that's not going to cut it anymore. This client needs their own private house. This is the separate databases model. This is the absolute pinnacle of isolation. Each tenant gets their own dedicated database instance. Sometimes they even get their own completely separate AWS account. We're talking total complete data isolation. The pros here are pretty much non-negotiable for any enterprise client. You get maximum security, guaranteed performance with zero noisy neighbor risk, and really straightforward backup and restore procedures. but the cons are just as big. This is by far the most expensive and the most operationally intense model you can possibly run. At this scale, managing potentially thousands of database connections becomes a monster of a challenge. A tool like AWS RDS proxy is pretty much a necessity. It sits right between your application and your databases, and it pools and reuses connections incredibly efficiently. This just dramatically reduces the load on each database, which is absolutely crucial for keeping things stable. For these top-tier, big-money customers, the motto is dead simple. There can be zero compromises. None. Not on security, not on isolation, and not on performance. That high cost is simply the price you pay to do business at the enterprise level. Okay, so we followed SauceWorks all the way from their startup days to playing in the big leagues. So how do you make this decision for your own application? Let's try to boil all this down into one single clear framework. This matrix really just lays out the core trade-off, doesn't it? If you look closely, you'll notice a direct relationship. As you move from left to right, from shared schema over to separate databases, the cost, the security isolation, and the operational overhead all go up together. Your choice really just depends on which of these factors is the most critical for your business at your current stage. Choosing the right model for today is important. But the most critical insight here isn't about which box you fit in right now. It's about how you're going to move between them tomorrow. Honestly, this might be the most important takeaway from this whole thing. You will likely move between these models. Your architecture is going to need to evolve as your company grows. So you should be planning for migration from day one. Really, think of it as a feature of your platform, not a bug or some kind of failure. It's a sign of success. And that leaves us with the final question you should be asking yourself. It's so easy to build for your needs right now, but the best architects, they're always thinking one step ahead. So are you building a database that can only support the company you are today? Or are you building one that can carry you into the future you're trying to create?